Go is an open-source statically typed concurrent programming language developed by Google. It is a popular choice for high-performance server-side applications. This language is used by popular applications such as Uber, Badu, Docker, and Dropbox. It is designed to be simple and easy to learn, making it a popular choice for building scalable web applications and command-line tools. Here is the main points about Go. Go is a compiled language. It means that the source code is compiled directly to machine code, which is executed by the processor. It makes Go faster than interpreted languages such as Python or JavaScript. Golang garbage collector automatically frees up memory that is no longer being used. This means that developers do not need to manually manage memory, which is time consuming. Golang is a statically typed language, which means that variable types are checked at compile time. You have to declare variable type or they have to be inferred. Concurrency is a feature of Golang that allows multiple tasks to be executed at the same time. Golang uses lightweight threads called Go routines, which are managed by Go runtime. While working on big projects, we have to deal with a large amount of code, and writing everything together in the same file will make our code look messy. In Go, we use package system, so we can separate our code into multiple files by keeping the related code together in packages. In this part of the video, we will install Go. If you already installed, you can skip this part of the video. Let's start. Open in the browser go.dev and click to the download. Choose operation system that you are using. I'm using Windows, so if you are using macOS or Linux, you can choose respective. Open the installation file. Next. You can change the installation path. I will leave the default one. And click to the finish. Now check if everything works. Open command line interface and write Go version. If you see the Go version, then you successfully installed Go. In this part of the video, we will install Visual Studio Code for local development. So if you already have it, you can skip this part of the video. Visual Studio Code is an amazing code editor that you can use for free. Search in Google for VS Code and open the first link. Choose operation system that you are using. I'm using Windows. Open the installation file. Accept the agreement, click to the next. If you want, you can change the installation path. I will leave the default one. By clicking to the finish, it will open Visual Studio Code. To have comfortable experience in developing Go, install extension Go. Click to the extension tab and search for a Go. It should be the first one. The creator is Go team at Google. So I already have it. You should have here install and enable it. Also enable autosave features, so you don't have to save a file after every change. It's in the file and here autosave. Now let's create a folder for our Go files. Click to the open folder. Whenever it's comfortable for you, I will write here, create a new folder like projects. Here, Go. And click to the select folder. Trust the authors. Create a file with the Go extension. I will call it app.go. And that's it. We are ready to write our first Go program. Let's write our first hello world program. We have to start with the package main. This means that the file belongs to the main package. The main package is special. It is the entry point for executable Go program. All Go program starts with the main function. Inside the main function, we are calling println function from fmt package. If you are installed the Go extension for VS Code, it will automatically import the fmt package. If not, you have to write this line manually, which is importing the package. To run this application, we have to write in the terminal go run app.go. Go run command takes the following file, compile it to executable, save it in the temporary direction, and then runs the program. After running the program, we should see hello world in the terminal. In this part of the video, we will learn about variables. Variables are a fundamental part of any programming language. Like many other programming languages, variables are a way to store and access the data from memory. Variables have a name, type, and a value. To declare a variable, use the var keyword followed by the variable name and type. Here I have variable age, which type is int. It means that it can hold integer values. We can see that we have an error that the age variable is declared and not used. This is a problem in Golang. We should use all declared variables. If I print the variable value, the error will gone. To initialize the value, we need to use an equal operator. In this example, I am assigning value 30 to variable age. Go also support type inference, so we can ignore writing the type if it can be inferred from the assigned value. For example, in this case, I can remove the int and Go infers that the age variable type is int because Go already knows what I am keeping inside the age variable. We can also declare and initialize variables in shorter way using the colon equal operator. Here I can declare another variable age1 and assign a value. In this case, I don't need the var keyword and the type declaration. We can always change the value of a variable later in the program by simply assigning a new value. For example, if we have an age variable whose value is 30, we can change it by writing age is equal to 40. Go also supports constants, which are variables whose value cannot be changed once they are set. Constants are declared using const keyword. Let's declare here, for example, the p constant and print it. Now try to change the value. We can see the error message. So if you have some variable and you know that the variable value will never be changed, you can use the constant. In Go, it's possible to declare multiple variables at once by separating them with commas. For example, here James is assigned to the name variable. Similarly, 30 is assigned to the age variable. The same code above can also be written in the shorter way. In Go, data type specifies the nature of the data that variables can hold. Go is a statically typed language, which means that variables are associated with specific data types at the compile time. Let's start with basic data types in Go. We already used an int type. Int is a basic data type, which values can be whole numbers, including 0, positive, and negative numbers. We also have an unsigned integer, uint. Unlike the int type, uint can only hold positive numbers. In addition to int type, we have also int8, int16, int32, and int64, same as for uint. It is specifying how much memory will be used to store the data. For example, int64 can store much larger numbers than int32, but it will use 2 times more memory. The float type is used to hold values with decimal point. Unlike int type, we have only float32 and float64 sizes. If we define float variable without specifying size, the size will be automatically 64 bits. Also, you cannot do arithmetic operation with different types. You have to first convert variables in the same type. Let's talk about string types. String can be created using double quotes or backticks. One of the differences is that you cannot add a new line in the string if you are using double quotes. To add a new line in the string with double quotes, you can use a specific symbol \n. With double quotes, you can also concatenate strings using the plus symbol. Boolean data type represents only one bit of information. It's either true or false. In previous examples, we always initialize the variable value, but it is not required. We can declare a variable and not set any value. Let's create a different type of variables and see what is their default values. If we run the program, we will see that for the int data type, we have a default value 0. For string, we have an empty string, and for the Boolean type, we have a false. The print statement is used to output some values or variables in the terminal. We have three most used functions in Golang, and all of them are from the FMT package. So let's first import the FMT package so we can use these functions. This is print, println, and printf function. Let's start from the simple one. It is print function. Using print function, I can output the value. For example, I can write hello in the terminal. If I will run this application, I will get this value in the terminal. I can use this function as much as I want. I can copy paste and add here world. I will add also here space that this word will be separated. We can see hello world in the terminal. Now let's write an example with the println. This is the second function, and see what is the difference between print and println. I will write the same example. I will write here hello and world. As you can notice, I removed the space from here. If I will run this up, I will get hello and world. The difference, as we can see, is that after hello, we have a new line and world. So basically the difference is that by default println adding a new line after printing a value. Using println method, we can also add multiple values or variables inside println function. For example, I can add a comma and put another value. For example, I can add here a world, and let's print to see what is the difference. We can see that also println, when we are adding multiple values, it automatically adds a space between these values. Let's also add some variable. I will create variable name. I will assign some string value to it. If I will run this up, I will get hello, my name is James. Now let's look into a printf function. The printf function formats the string and show it in the terminal. Let's see in the example. If I will run this up, I will get the age is 26. Here the printf function replaces the percentage sign and d with a value of variable age. The percentage sign and d is a format that replaces an int type. For other data types, we have different specification. For example, if I will have here like name, which will be string, I can add actually here name, but we will get some kind of warning that this is a wrong type. So for the string type, I have to write percentage sign and s. In this case, I can print it and I will see the age is James. So the different variable types, to get the value of the variable, we have to add its own specification. I will write for the simplest one, for the integer, float, string, and boolean, but there are actually more. We just will write here the most used ones. we can see here we have different specification for different variable types. For example, for string we have %s, for integer we have a d, for float we have g, and for boolean we have a t. And also all of them are in lowercase. Now let's run the application. And we can see my name is James, I'm 26 years old, I have 55.6 US dollars, and some boolean false, as we specified here. There is also one specification that is actually used a lot. This is %, and in the uppercase T, which is actually showing the variable type. So basically this will show the variable types of these variables. If I will run app, I will get variable type string, which is the first line, variable type int, variable type float 64, variable type boolean for the latest one. Also we can add a \n, which will add a new line. So after every print, I can remove from the last one, we will add a new line. And we can get this. The name is string, the age is int, the money is float 64, and the married variable is boolean. Also, a format can have different specifiers. For example, I will remove all of these. I will use these two variables into one format. Here I can pass two variables for the string, which was name, and for the age, which will be for this integer. If I will run the application, I will get hello, my name is James and I am 26 years old. In this way, we can replace in the string the values with the variable value. Now we will learn how to handle user input using FMT package. Let's get started. We can use scan function to take input from the user. Let's write an example. We need to import FMT package. Now write scan function and inside pass the pointer to variable name. And let's print it. So we defined the variable name. We are printing the name in the terminal and calling scan method with passing name variable. Here, whatever user will input, we will have in name variable, and after we will output hi and name variable. Let's run the application. Okay, now we have a name, and let's write a name, James, and we will see output hi James. The scan function can only take input until space. If you pass one variable, the value will be cropped until space. So if I will write James and after space and another name, it will be cropped until space. However, scan function can take multiple inputs from the user. For example, if we need a name and also a last name, let's define the second variable. Now we have to put into scan function the second variable, which is last name. And let's also add it in the output so we can see. Let's run the application and write John Smith. We can see hi John Smith. So here after every space it will put on the variable. So the first word that I wrote it's a John and the second word is a Smith. So it will be respective. The name will be John and the last name will be Smith. If I will write three names, for example, John, Smith, James, we will see that the James will be cropped. We will get only these two words. Let's talk also about a scanf function. The scanf function is similar to scan function. The difference is that scanf takes input using format specifiers. For example, let's replace the last name with age variable, which will be type of integer. So here we will have name and age. Here we will replace the function with the scanf, and as a first argument, we will pass the types. So for the string, it will be %s, which is for the string. And for the age parameter, it will be %sign and d, because it's an integer. Now we can also output it here. Let's print age here and run the app. Okay, now I will write James and 35. In this example, function takes value separated by a space. When I encountered new line, the scanf stops taking input values. Almost all programming languages have a comments in code. Comments are lines in a program that explain how the code works and or why it's written. In Go, there are two types of comments. There is a single line comment and there is multi-line comments. In Go, we use 2 slashes to create a single line comments. For example, we can write at the top of the comment while we are doing it. We can also use single line comment in the same line as the code. For example, in this example, the compiler executes the code statement before 2 slashes, this part, and ignores everything after and including 2 slashes. We have also multi-line comments in Go. For example, we can write like, and now everything inside here will be comments, so we can write whatever we want. But to be honest, multi-line comments are mostly used for debugging and testing purposes. In regular use, multiple single-line comments. Operations are special symbols that perform operation on variables and values. Let's start with arithmetic operations. These are used for basic mathematical operations. Let's see the most common used ones. So basically, this is the mathematical operation. We have addition, subtraction, multiplication, division, and modulus. We see here in the comment the output, but I will run the app to see also in the terminal. Next up, we have relational operations. These are used to compare two values. The result is always a Boolean value, true or false. Here they are. As we can see here, we see them as a result true or false. These are mostly used in conditional statements. Welcome back. Today we will talk about conditionals. Conditional statements are like decision makers in programming. They help the code figure out what to do based on certain situations. So sometimes the code runs and other times it doesn't, depending on conditions. The most basic conditional statement in Go is the if statement. It allows you to execute a block of code if a specific condition evaluates to true. The basic syntax in Go is like this. We start with if, after we have to write a condition. If the condition is true, the statement in the curly brackets will be executed. We call this a block of code. Optionally, we can have another condition. We can write that else if another condition. And write another statement. We can add as many conditions as we want. There is no limitation. Also, we can add else, which will execute the statement when above conditions will be not true. Now let's write some example. Imagine you have an application that should check if user balance is enough to buy a product. Let's create a variable balance, which will be user balance. The type of the balance is int and it's equal to 200. And we will create also another variable, which will be product price. It will be also integer and it will be equal to 115. Our application will check if user balance is enough to buy a product, and based on that, we'll show some message. Let's write a condition. If balance is greater or equal to product price, then we will output in the terminal that your balance is enough to buy a product. Okay, otherwise, so in this case, if it's not true, it means that if product price is greater than balance, this is the else case. If product price is greater than the balance, we will write a message that your balance is not enough to buy a product. This is our simple example. Let's run this application to check. We can see message, your balance is enough to buy a product. Yeah, we see that balance is greater than product price. Now let's change the balance and make it less. Like in this case, we have a balance which is 100 and we have a product price which is 150. In this case, balance is not greater or equal than product price. It means that this condition will be false and should be executed else statement. Let's run the application and we can see that your balance is not enough to buy a product. Welcome back. In this video, we will explore about combining conditional statements in Golang. The conditions can be combined in the two following ways. We have AND, which syntax is to AND, and also we have OR. For OR, we are using two pipes. If we are using AND, it means the statement will be executed only when two of the conditions will be true. In case if one of the conditions or both of them are false, then the statement will not be executed. Let's write some example. Let's create a time variable, which type is integer, and it's equal to like 15. And now let's check if the time is greater than 9 and time is less than 17, then we will output the string in the terminal that the office is still open. Okay, let's check what we have here. We have time variable, which is equal to 15, and we have here a grouped condition with the AND. It means that this statement will be executed only in case if both of the conditions are true. So let's check. We have 15. 15 is greater than 9 and it's smaller than 17. Let's also run the program to make sure that everything works. I will write go run and app.go. We can see that the office is still open. Now let's use our way of grouping. Let's write a second condition with the groups. We can say if time is less than 9 or time is greater than 17, then we can output that the office is closed. Okay, let's see what we have here. We have time variable, which is 15. Let's change this value to like 5. Now we have here two conditions grouped by or, and we have time variable, which is 5. What it means? 5 is less than 9. It means that this part of the condition is true, and 5 is not greater than 17. It means that we have in the left side true, and we have here false. In this case, the statement will be executed, because when we are grouping with or, even if one of them are true, then the statement will be executed. Let's run the program to check it. We can see that the office is closed because this part is true. Now let's write another number. Let's say 25, which means that this part now will be false and this part will be true. Let's run the program. And we can see, yes, the office is still closed. Welcome back. In this video, we will talk about switch statement. The switch statement is used to perform different actions based on different conditions. It is alternative to if condition. Let's write some example. Okay, our example is ready. And let's see what we have here. We have integer variable which called day of week. I set value 3 as a day of the week. We are starting from Monday until Sunday, and also we have invalid day if there is a wrong value. What is happening here? Day of week value is compared with the case values with these values. And in case of the match, the code is executing. In our case, we have 3 and we have case with the 3. It means that if we will run this program, we will have in the terminal Wednesday. Let's check it. Let's clear the console and go run app.go. We have Wednesday because yes, the case is matching with that. If we will change the value to 1, we should have now Monday. And also let's check a value which is not matching with anyone. For example, 10 or 90. We see invalid day. So what is happening if we don't have match with none of the cases? The Go is executing the default case. Welcome back. In this video, we will talk about arrays in Golang. Arrays are used to store multiple values of the same type in a single variable, instead of declaring separate variables for each value. Let's declare some array. We are starting with the var as usual. After we are writing a variable name, I will call it nums. And for the array, we have to specify the length of array, how many values can array contain. We have to write it in the square brackets. So in this case, I will write 3. And after closing square brackets, we have to specify also the type of the values that array will contain. I will write int because I want to store integer values. Now let's print this variable and see what we have inside. And we can see in the terminal 3 zeros. It's because I didn't add any values and it gets default values for integer type, which is 0. Let's add some values to array. I will remove this and create another variable like var nums is equal to, first I am writing the length of the array, which is, let's say 3. The type will be the same integer. And in the curly brackets, I am writing the values that contain array, like 1, 5, and 6. Let's print the array and we will see 1, 5, 6 as we have here. The length specifies the number of elements to store in the array. In Go, arrays have fixed length. The length of the array is either defined by a number or inferred. Let's write an example with inferred. I will create in this time array that contains strings like cars. And to infer the length of the array, we have to put 3 dots. After square brackets, we are writing the type. In this case, it is string. and let's add some values. Okay, let's now print the cars instead of nums. So we can see our array with strings. Each element in an array is associated with a number. The number is known as an array index. We can access element of array using the index number. Index is starting from 0, so for our example we will have these indexes. Like I will write in the bottom, the index for BMW will be 0, for the Ford 1 and 2 and 3. So index is starting from 0, not from 1. So the first element index, it's the 0. Now let's get some specific values from this array. So for example, if I want to get the BMW, I should write in the square bracket 0. If I will run the code, I will get BMW. If I want to get the Mazda, it will be 0, first and second. So I have to write 2 here. Perfect. And also we have a method len, which we can use to get length of an array. Let's say I want to know how many values are in the cars array. I am writing len method, and as an argument I am writing cars. So let's print it. We will see 4, 1, 2, 3, and 4. We can also create an array and assign the values later. Let's create an array with 3 length, which will contain integers. Okay. We can initialize the values later, like nums, the 0, 1, with the 0 index is equal to 4, nums with first index is equal to 2, and nums with the 2 index equal to 5. Let's also print this array. We can get 4, 2, and 5. If I will create another one, like with the third, I should get an error because we already said that this array length is 3 and we cannot create fourth one. Welcome back. In this video we will learn about slices. Slices under the hood are arrays, often used in a place of arrays because of their dynamic size and added features. When we are creating a slice, we are not specifying how many values the slice will contain. Let's write some example. In Go there are several ways to create a slice. So first way is very similar to creating an array. So let's write it. I will create a variable with the name custom slice. So we are starting with square brackets is an array, but we are not specifying how many values the slice will contain, as we are doing in array. And after square bracket, we are writing the value type that will contain. In this case, I will write int and curly bracket. In this example, we are declaring an empty slice of 0 length. To initialize the slice during the declaration, we are writing the same, just in the curly brackets, we are writing the actual values, like print our variable. And we can see it is working. In Go, there are 2 built-in functions that can be used to return the length and capacity of a slice. So about len, we discussed about it in the array video. It's basically the values count inside the array. We have the same here. We can use the len function. Let's duplicate this line and print the len, which is showing the length of the array or a slice. Also, we have a built-in function cap, which is return the capacity of the slice. So what is the capacity? Capacity, the number of elements the slice can grow or shrink to. Let's run this code and see what we have here. Okay, now we see this is our slice. this line, seventh line, and also we have a len, which is 3, and also we have a capacity, which is also 3. When the elements are specified and both and the capacity is equal to the number of actual elements that is specified. Now let's create the same, but for empty slice. I will copy paste the same. I will remove the values, the elements, and I will add here one custom slice 1 here and here and here too. Now I'm running the code and we can see, we can see that slice is empty and length and also the capacity is also 0. Now let's check another way to create a slice. It's creating a slice from an array. Let's write some example. Okay, let's see what we have here. I am creating here an array that we have created in the previous video. So the difference is you see that we have here fixed value, that the length of the array is 5. And we also initialize the values. We have here integer values. And in the seventh line, which is very interesting for us, because here we are creating a slice from an array. We are saying that create a slice from my array, which is this one, from starting point first, this is the index, until third one. So what we will have here, it will create a slice and we'll get from the array starting from first. As you remember, the index is starting from 0. So the 0 element is 10, first one is 44, until the third one. So 0, first, second, and third. And one thing, we are including the start element, it's a 44, but we are not including the end point. Let's say if we are writing until third, we are not including third element to our slice. If you can see in the console, in the terminal, it's starting from 44 and it's ending until 53, which is the second element. We have here also the length and the capacity. The length is 2 because we have 2 elements inside our slice, but the capacity is 4 because the slice can grow to the end of the array. This means that the capacity of the slice is 4. Okay, let's now check how we can create a slice with the make function. The make function can be also used to create a slice. Let's write an example and it will be more clear. Our slice is ready. Let's run the application. So we are creating the slice in the 6th line here with the make function, and the first argument is a type of the values that will contain a slice, which is in this case it will contain int. And also we say that the length of the slice will be 5. The second argument is a length, and the third argument is a capacity. We can see in the terminal, as we didn't initialize any value, that's why we have a 0 values, because it's the integer type. For the length we have 5 and the capacity of the slice will be 7. We just successfully created slice with the make way. Also there is one note, we can remove the capacity, and what will be happen now? If we will run application, we will see that the capacity, in case of not writing the capacity as a parameter, it will be the same as the length. Welcome back. In this video we will talk about for loop in Golang. A for statement is used to execute a block of code repeatedly. For example, if you want to do same thing 100 times, it's not a good idea to copy paste the code the same amount of time. There is a couple of basics for loop patterns. We will check most of them. The syntax is pretty similar to other programming languages. We are starting with the keyword for and after curly brackets, and inside the block we are writing our code. Let's print something. Now if I leave the code as it is, the program will never end. Let's run this application. And as we can see, it's trying to type a hey as much as it's possible. We have to leave with the keyboard or close the terminal because it will never end. And that's why we need to somehow say that the loop is enough and to limit the loop. So for it, we can add some condition. Let's try it. Let's initialize some variable. I will call it num. The type will be integer and it will have 0 value. So, and we can add a condition here. We can say that do the code of block until num is less than 5, for example. Okay, what we have now here, we have num which is 0, and every time the num will be checked. Num 0 is less than 5, yes, and it will be executed. 0 is less than 5, yes, it will be executed. And it will be the same infinite loop. That's why we need to somehow change the num value. For every time, for example, increase it with 1 num variable. So what we will have now, the code will be executed. Num will have 0. 0 is smaller than 5. Will be printed hey, and num will become 1. It will be added to the previous value 1. In the fourth iteration, in the fifth iteration, when num will become 5, 5 is not less than 5, and the loop will be finished. Let's check it. We will see 1, 2, 3, 4, 5, 5 times. We can also follow the num and we can print it and see how it is changing. We can see 0, 1, 2, 3, 4, 5. 5 isn't working because we said that it's less than 5. If we will say less or equal and run the application, we will get also the 5. There is another style for loop which is more practical but doing exact the same thing. We can remove this num++ because we will move it to here, and also defining the variable. So these two things we will move to the for, and we can init our variables here. So first part is we are initializing the variable, second part is the condition, and third part is the action, like plus plus. So we have exactly the same, but it's more compact way and I like it more, to be honest. Run the application, we will get exact the same thing. Now imagine you have an array or slice or group of values that you want to output with the list. You can use for each range loop. Let's write an example and it will be more clear. Let's create some slice which will contain string, and let's add some cars. Let's do for loop for these ones. Our example is ready. So what we have here slice, which contains 4 elements: Audi, BMW, Porsche, Ford. All of them are strings, and we want to output all of them. We have here key, which is the same as index, like it's 0, 1, 2, 3. And we also have a value which is Audi, BMW, Porsche, and Ford. And let's print it out. Yeah, we can see Audi, BMW, Porsche, Ford, it's a value, and we have also keys, which is index of slice. We have also two special keywords, the break and continue, where they are used. Imagine we have a case when, let's say, we have to output all of these elements, but when we will see a Porsche, we want to stop there. We don't want to continue. So we can add a condition and say, okay, if the value is equal to Porsche, then break. So what is break doing? Break statement leaves the for and just exit it. When the code will execute break command, it will just leave the loop and continue from like here. Let's run the code and we'll see. Audi, BMW, and in this iteration, it is checking that it equal to break, and it just leave the for loop. And we also have a continue. Let's replace here. And continue is similar, but doing like this. When it execute continue, come back to the for and execute from here. Like it's skipping that one iteration. If it's a Porsche, in this case, it just skip that one, come back and continue with Ford. Let's execute and we will see. Audi, BMW, and after the Porsche is skipped, and we have also Ford. Welcome back. In this video we will talk about maps in Golang. A map in a Golang is a data structure that allows us to store data indexed by a unique key. Unlike arrays where we can get values using the position in the array, in the map we can get with the key which is mapped to some value. Let's create an example with the map. We will store as a key the city names and as a value their temperatures. Let's start as usual with the var. Name of the variable, I will call it my map. And after we are writing keyword map, in the square brackets we are writing the type of the case. And after closing square brackets, the type of the values. In this case we will have a city names which will be string and the temperature which will be integer. And we have to write same after equal. And in the curly brackets, we can identify the values. Now let's print our map. We can see that our map is ready. We have a key in the left side and the values in the right side. So we have Barcelona, Lisbon, and Paris with their values. So we can access to these values using these keys. Like if I want to know the temperature in the Lisbon, let's copy paste this line. I can write in the square brackets the key that I need, like Lisbon. Let's run the application. We can see that in the Lisbon, there is 25 degrees. In Paris, there is 18 degrees. There is also a way to create a map using the make built-in function. Let's write that example too. Let's remove this one. We created a map using make function, but we leave it empty. We can see that map is defined, and now we can also add the values to my map. Let's run the app. And we just created a map using make function and added some values to there. Let's add one more value. Also, we can use built-in function for maps, like we can write len to see how many k value pairs we have. We see that we have 1, 2, and 3 k value pairs. Now let's imagine the situation where we want to list this map. We can do it using range form of the loop, which is iterates over a map. Let's write it. Let's run the application. We can see Lisbon 26, Rome 28, and Berlin 17. We are using here range form of the loop, which is iterates over the map. And we have here the k of the map, and also we have a value of the map. Let's remove it. Let's also discuss about deleting element from the map. To delete element from the map, go have a built-in function delete, where you have possibility to delete element from the map using k. To do that, let's first output. Let's run the application. We see that we have Berlin, Lisbon, and Rome as we identified here. And I want to remove the Berlin. I have to write, I need to delete. First, we are identifying from which map, from my map. And in the second, we have to write what K we want to remove. Like in this case, it's Berlin. Let's run the application. And we can see that Berlin doesn't exist anymore. Now imagine a situation when we want to check if the K exists or not. To do that, the syntax will be this means that if the K exists, the K is here Lisbon, store the value into the value variable. And if not, then store the default value for the given data type. As we are using integer here, then the value will be 0 if the K will not exist. If the K exists, then OK will return a true. If not, then OK will return a false. Let's print this variable. In this example, we have a Lisbon K, which is exist. And let's run the application. We can see that we have 26, which is value for the K Lisbon. And also we have true because it is exist. Now let's write offense and run the application. So this K doesn't exist and we get 0 because the default value for integer data type is 0. And we also get false because this K is not exist. Welcome back. In this video we will talk about functions. A function is a block of code that performs a specific task. Functions in Go follow the same concept, allowing you to write reusable, modular, and organized code. Let's create a simple example. We are creating a function using the keyword func. Following say hi, which is the name of the function, and cont inside curly brackets indicates the function body. Let's run this program. When we run this program, we will not get the output. This is because we are just defining a function. To execute a function, we need to call it first. We use the function name following the brackets to call a function. In the main function, I will write say hi and brackets. Now, if I will run the app, we will see the message in the terminal. We can call function as many times as we want. So I will call now 3 times and I should get 3 times the same message. Let's now write an example where the function will work dynamically and will output the sum of 2 numbers. First, we need to define a function with parameters. A parameter is a variable used to pass information into a function when it's called. I will call my function name is print sum. And here our function will get 2 parameters, num1 and num2. Here int means that both parameters are integer type. The arguments are assigned to function parameters when we call the function. Okay, now let's print sum of these 2 numbers. Now let's call the function. When we're calling the function, we need to identify the parameter values, like 10 and 5. The arguments are assigned to the function parameters when we call the function. 10 is here assigned to the num1 and 5 is assigned to num2. Run the application and we will get 15. If we call another one, now our function is more dynamically, it performs its task with printing the sum. We have 15, which is 10 plus 5, 60, which is 20 plus 40, and we have 110, which is 60 plus 50. In this example, we print the value of the sum inside the function. However, we can also return a value from a function and use it anywhere in our program. Here's how we can do that. Now, after closing bracket, we have to identify the type of the returnment value, and in the code, write return and return the value. So here I am returning num1 plus num2. Let's remove these ones. The function returns value in the place from where it's called. So we need to store the returned value in a variable. For example, we have to write. And now we can print the result variable. Here we are storing the return value to the result variable and we are printing it here. Let's run the application and we will get 15 because 10 plus 5, we are storing it in the result and printing the result. The return statement should be the last statement in the function. When the return statement is encountered, the function terminates. So this is our end of the function. Also, functions support returning multiple values from Go function. In Go, we can return multiple values from a function simply by listing them in return statement, separating by commas. Let's write another example. Here we are returning multiple values. We are returning two values where first value is multiplying num1 and num2, and as a second value we are returning num1 divided by num2. We have to specify the returnment value type after closing brackets in the parameters part. So here we're saying that both of the returnment values are integers, and when we are calling the value, we are assigning it to two variables and then printing them. Let's run the application and we can see we have two values, 50 and 2. So because first we are multiplying 10 and 5, and in the second value we are dividing 10 divided by 5, which is 2. Welcome back. In this video we will talk about anonymous functions in Golang. Anonymous functions basically functions without names. Here's a little example. This is anonymous function, and since an anonymous function does not have any name, we might be wondering how we can call this function. Usually what we do is assign an anonymous function to a variable and then use the variable name to call the function. Let's write it. Here we can see that we have used the variable name say hi to call a function. Like a regular function, an anonymous function can also accept function parameters and return a value. Let's write some function which will return the sum of two numbers. In this example, our anonymous function, which we assign to variable sum, accept two parameters num1 and num2. Both of them have integer type. And also we return the sum of them, and the sum is also integer. Here we assign the return value from the anonymous function to this result variable and print it. Let's clear the terminal and run this application. And we see 6, which is what we expected. In Go, we can also pass anonymous function as argument to other functions. For example, let's see what we have in this example. We have created two functions, an anonymous function where we are returning the sum of two integer values, and we have a regular function multiplied by 2, which is returning the same number with multiplying by 2. And in this example, what will happen? So first we pass 6 and 5 parameters to our anonymous function, which will be sum and will be 11. And after we'll work multiply by 2, which will multiply 11 to 2, which will be 22. Let's run the application and we can see 22. Welcome back. Today we will learn about variable scope in Golang. Understanding variable scope is super important for writing clean and efficient code. First, let's talk about the two main types of variable scope in Go. This is global scope and local scope. Let's write an example. Here I have declaring a variable called global var outside of the function. Now within our main function, let's declare a local variable named local_var. The local_var variable has a local scope, meaning it's only accessible within main function. Let's print these two variables. We see that it is working, so both of the variables are accessible within main function. What is the difference? Local_var variable is declared within main function. It means that it is accessible only in the main function. If I will declare another function, and I will try to access a local variable here, I should get an error message. We already see from Visual Studio Code that undeclared name, but if we will run the application, we will see the same, undeclared name local variable. It is because local variable is defined within the main function. For the global var, I can print it out into another function because it's accessible from here too. Variables in Go have either global scope or local scope. Global variables are accessible from anywhere within the package, while local variables are only accessible with the function in which they are declared. Understanding variable scope is crucial for writing clean and maintainable Go code. Welcome back. Today we will learn about modules and packages in Go. A package is a directory of Go files. It helps us to organize code into reusable components. But a module is a collection of packages with built-in dependencies and versioning. A module comes with the two additional files, GoMod and GoSum. Let's write an example. First of all, we need to run GoMod init and the module name. The command creates a GoMod file. To track the code dependencies, it includes information about the module's name, version, and dependencies. If we open the file, we will see the module name and the Go version. Later on, we will see here also the dependencies. We already used some of the built-in packages like FMT. Now let's look how we can use an external package from GitHub in our program. We can do it using go get command. It is used to manage packages and modules. Let's install Zerolog package. It is one of my favorite external packages, and to use it I need to run go get and the path. We can see that it's successfully added and we have some changes as a requirement in the Go mod file. After downloading the package, I can use it in my program. We can see that it successfully works. This is a way how to use an external package. Now let's create our own custom package. While working on mid to big size projects, we have to work with a large amount of code. And writing everything in the same file will make our code looks messy. Instead, we can separate our code into multiple files by keeping the related code together into packages. To create a package, first of all, we need to create a folder in our program. I will call it utils. And inside the utils folder, create a file. For example, I will call math.go. I will add here some helpers function that related to some math operation. Usually we give the same names to the packages and the folder. So I will call package utils. Let's add two functions inside the math go. One of them will return the sum of two integers and the second one subtract the value. Now let's use the sum function in our app.go file. Let's remove this and instead import fmt package. Now I can call a function from utils package, a sum function. we can see 9. So we successfully created our oven package and used the function inside it. Now let's talk about visibility. Unlike the other programming languages like PHP or Java that use access modifiers such as public or private, Go specifies if an item is exported or unexported. Exporting an item in this case makes it visible outside of the current package. If it's not exported, it is only visible inside the package. The external visibility is controlled by capitalizing the first letter of the item. All declarations such as variable, constant, functions that starts with a capital letter are visible outside of the current package. As you can notice, the subtract function from the math.go file is started with a lowercase. It means that the subtract method is accessible within the math.go file, and if we try to use it in main.go, we will get an error. Let's check it. Visual Studio Code already shows us that there is only one accessible function. We will get that this is undefined. And now if we will change the first letter with uppercase, we will change here also. We will see that it will start work. Welcome back. In this video we will learn about struct type in Go. Struct is used to store variables of different data types. For example, imagine you have an employee and you want to store his name, age and salary. You can create 3 variables, name, age and salary, to store the values. Now imagine you have multiple employees and want to store the same information for each one. This is where struct can help. We can design a struct that stores the value of the name, age and salary for each employee. Let's start with example. To declare a struct, we start with the keyword type following the name of the struct. In this case, it is employee and struct keyword. Inside the curly brackets, the struct contains variables. Let's declare them. The struct contains 3 variables, name, salary, and age. Now let's create an instance for this struct. We just created an instance. We set the values by the order. It means that John will be our name, employee name, 6000 will be salary, and 13 will be his age. Let's print it. We see our struct. We can also access individual elements of a struct using dot symbol. If I want to get the employee1 name, I can write employee1 dot name. We can see John. The same as for the salary and age. We can create for the same struct as many instances as we want. So let's create 2 more employees. Here we have 3 employees now and we can access all of them. And let's print all of employees' names. Here we have. Welcome back. In this video we will learn about methods defined in the struct. Methods in Go are functions associated with a specific type known as a receiver. The receiver can be of any type, but it's often a struct. The receiver is defined between the func keyword and the method name. Methods provide a way to add behavior to user-defined types. By defining methods on types, we can make the types more powerful. For example, let's create a rectangle struct. We could define area method on the rectangle type. Now we can call the area method on instances of rectangle. This Go code defines a rectangle struct with 2 fields, width and height. Both of type float 64. The struct also has a method named area, which calculates the area of the rectangle. In the main function, the area method is called on the instance R, and the result, the area of a rectangle, is printed in the console. This makes the code more readable and intuitive, as we are asking the rectangle for its area rather than passing the rectangle to a function. Welcome back. In this video we will learn about interfaces in Go. Interface groups types together based on the methods. They are defining a contract for a certain methods. Interfaces are crucial for several reasons. They allow us to write functions that can take in different types, as long as those types satisfy the interface. This makes our function much more flexible. They also make it easier to test our code by mocking interfaces. Let's write an example. We are defining dog and cat structs, each with a name field. We also are creating an interface named animal, which is declaring a single method speak. Both structs implicitly implement an animal interface by defining a speak method with the same signature as the interface. Let's implement also the speak method for both dog and cat structs. When called on a dog object speak method, it prints the dog's name followed by the says woof. When called on a cat object, it prints the cat's name followed by the say mew. This interface is used to define a contract for types that can speak. A function speak animal is defined, which takes an animal interface as a parameter. Inside this function, the speak method of the provided animal interface is called. Creating the main function, dog and cat object. Dog object name can be body and cat object name can be whiskers. And call speak animal function twice, once for a dog object and once for a cat object. Since both dog and cat types implement the animal interface, they can be proceed as an argument to speak animal. After when speak animal is called, with each object it invokes the appropriate speak method based on the object type, printing the corresponding sound each animal makes along with its name. Welcome back. In this video we will talk about pointers. So what is a pointer? To understand what is a pointer, we need to first understand how memory works. Here is an example of a memory where we have an address and a value. The address is a location of a memory, and the value is the data stored in that location. And what will happen if as a value I will store another address? With this action we will create a pointer. Let's start with an example. Create a string name and output the value in the terminal. Nothing special, we will get the value. Now, in the new example, add an ampersand before the variable name. In this case, we will get the address. So if you see ampersand before the variable name, you can read it as address of the variable. To get the actual value instead of address, we need to add a star before variable name. And in that case, in the terminal, we will see the actual value, because it's the value of the variable that name1 is pointing to. I can even change the value of name variable using pointer name1. I am creating variable name, which type is string, and assigning value James. Name1 in this example is a pointer variable that stores the memory address of variable name. It's initialized with the memory address of name using the ampersand operator. So name1 holds the memory address where the value of name is stored. Star name1 is used to access the value that name1 points to. This is called dereferencing. So name1 gives you the value stored at the memory address stored in the name1. And in the code star name1 is equal to Alex, we are assigning the value Alex to memory location that name1 pointing to, which is the same memory location as variable name. So effectively we are modifying the value of name indirectly through name1. When we print name, we will see Alex because we modified its value through name1. We can also create a pointer variable by this way. Here we have created the pointer variable named pointer that stores the memory address of the num variable. Int represents that the pointer variable is of int type. We can also create pointer variables of other types, for example. As an output for pointer 1 and pointer 2, we will get a nil. Welcome back. In this video we will talk about empty interfaces in Go. Empty interfaces might seem a bit mysterious at first, but once you understand them, you will find them to be quite powerful. So what exactly is an empty interface in Go? Well, an empty interface is an interface type that has zero method. In other words, it doesn't specify any behavior. Let me show. I am creating a function called describe that takes an empty interface as a parameter. That means that describe can accept any value of any type. And let's call describe function in the main function to see a result. And now I call describe function 3 times and pass different type of variables. First we have a integer, second we have a string, and we also have a boolean type in third call. Let's now run the application. We see that we have an output of all variables. It is because now our function, which is called describe, can accept any type of any variables. Now you might be wondering, when would you use actually empty interfaces in your code? Well, one common use case is when you need to work with the values of unknown types, such as when dealing with data of different types. Let's write an example. In this example, depends on the passed value, we will show the different messages. Let's run this app. And we can see we call 3 times the describe function, and for the first time we see that this is an integer because the type of this value is an integer. For the second time we have a string, this is a string, and for the third time we have this is something else because we don't have any condition for boolean type, and that's why it's running the statement for a default. We can also pass a variadic parameter type, which means that we can pass any number of arguments into that parameter. The function will receive the list of arguments for the parameter as a slice. We should add the 3 dots before parameter type. Now we can pass as much arguments as we want. I will just add here the print statement. Now I will call one time describe function, but will pass multiple values. And we will see all of the values that we passed here. Welcome back. In this video we will learn about defer in Golang. Defer allows a function to postpone the execution of a statement until the wrapper function will be completed. This can be useful for cleaning up resources such as closing a file or unblocking a mutext. As the function calls are placed on a stack, they are called in last in first out order. Let's write an example. The syntax is pretty simple, you're just adding a defer before the function call. In this example we will get an output high and after by, because with defer function we are postponing the execution until the main function ends. As I mentioned, the defer statement will run in last in first out order. It means if I will call on 3 defer functions, the function will be started from the last one. In this example, as an output I will get 3, 2 and 1. Using defer to clean up resources is very common in Go. Let's first look at the program that creates a file, and we are using defer keyword to terminate the file. Here we are importing OS package and using create function to create a file. After, when we are making sure that there is no error, we are calling file.close. The deferred file.close function ensures that the file is still properly closed before the program exits. Without defer, you will need to manually call close function before every possible return point, which will be fallable and make the code harder to maintain. Welcome back. In this video we will learn about panic statement in Go. Panic is a built-in function that stops the control flow of your program. We use the panic statement to immediately end the execution of the program. If our program reaches a point where it cannot be recovered due to some major errors, it is best to use the panic. It is used when the program reaches a point where it cannot be continued because of the errors. The syntax is pretty simple. We are writing a panic and in the brackets the message. Now let's also print something in the terminal to see how it works. I added two print statements, and as we can see already, Visual Studio Code tells us that the code will not reach here. Let's clear the terminal and run this application. We see the first message, hello, and after we see the panic and the string that we passed as an argument. Here the program is terminated when it reaches to the panic statement. That's why the print statement after the panic is not executed. Panic in the output specifies that the program is terminated due to the panic, and it's the panic message. We can see here the panic and the message that we pass here. When the panic is triggered, the Golang runtime starts checking the stack and executing deferred functions. However, if a deferred function calls the built-in recover function, the panic is stopped and the program continues executing normally. The Go compiler can also invoke a panic. Let's create two variables. Both of them are integers, and I will try to divide by the 0. In the terminal we see that panic runtime error integer divided by the 0. This panic invokes by the Go compiler. Not all panic cases should terminate the program. Some panic cases can be recovered. The recover keyword is used to restore the program from panic errors. Recover is only useful inside the deferred function. In a normal execution, a call to recover will return a nil. Let's write some example. The example is about recover, which is allowed to regain control of a panicking Go routine. It is used to stop the panic and return the value that was passed to the panic call. Here we are adding a panic with the message something went wrong, and also we are deferring function recover panic. Before the panic, the recover panic function will be executed. We will have a call to recover function. So inside our variable, we will have the panic message. In this condition, we are checking if R is not nil, which is the case when we have a panic. So if we don't have a panic, the R will be nil. But in this case, as we have a panic, the R variable will contain something went wrong. And here we are printing that recover from panic and the panic message. So if I will execute the code, I should have a start. I should have recovered from panic right after panic message, and also I will have an end. Let's run the app. And as we can see, start, recovered from the panic and panic message, and the end. Concurrency is a critical aspect of software development, especially in apps where performance and scalability are important. In this video, we will learn about concurrency in Go. Before starting, let's clarify the difference between concurrency and parallelism. Concurrency refers to the ability of a program to execute multiple tasks at the same time, while parallelism involves actually executing these tasks in parallel. If your machine has one CPU, your code will not run in parallel. So the concurrency is a design pattern that allows your code to potentially to run in parallel. At the basis of Go concurrency model are Go routines. A Go routine is a lightweight thread of execution managed by the Go runtime. Unlike traditional threads, which are managed by the operation system kernel, Go routines are managed by Go runtime, making them more efficient and cheaper to create. Creating a Go routine is as simple as prefixing a function call with a Go keyword. For example, let's see what we have here. We have two functions, say hi and say bye. Say hi printing in the terminal hi and say bye printing bye. We are starting from the main function, so if we run this application, we will get program starts, message in terminal. After we will call say hi function, which will print hi. Later say bye, which will print bye. At the end of the program, we will print program end. Let's do it in the terminal. Yeah, we can see the standard execution of this program. Now, if we want to run the function say hi as Go routine, we need to just add the Go keyword before the function call. So I will write here Go and say hi. After running this program, we will see that we have a message program start, bye, and program end. Let's first understand why we don't see hi message. The program starts from main function, so first we have program start message in the terminal, and after say hi function is invoked as a Go routine using the Go keyword, which means it will run concurrently with the rest of the program. Immediately after invoking say hi, say bye function is called. Later we have also print program end, and the main function reaches its end. And since there is no other blocking operation, the program is terminates. So the Go routine executing say hi may not have had a chance to run by the time the program terminates. So that's why hi is not printed. Now we will learn how to tell the app to wait until Go routines will be finished. Wait group is actually a type of counter which blocks the execution of a function until its internal counter becomes 0. Let's see in the example. Let's create a variable wg. Let's create it globally. It's automatically imported sync package, which we needed. Before launching the Go routine say hi, we are adding a 1. So we are writing wg. And we have here three functions, add, done, and wait. Here we have add, which is basically means that wait for one Go routine. We have to add some blocker at the end of the program. Basically, wait will block the terminating of the program until internal counter will not be 0. Now, inside say hi function, we are calling wg done. And inside the say hi function, we are calling wg done, which is decrease the number of things that we are waiting for. So in this case, it will be 0 and the program will not be blocked anymore. If I will click to the done using control button, we will see that it's doing wg add -1, which is decreasing the internal counter. And what will we have here? So imagine we have a sum counter which equals to 0. Here we are adding 1, so we have 1 now. And wg wait will block the termination of the program until this counter will not be 0. We are creating say hi Go routine, but our program is continuing to execute. And our say hi is still not finished. In the 27th line here, it's blocked. And it will be blocked until our code will not run wg done, which will decrease the internal counter with 1, and when the counter will be 0, our program will be terminated. Let's run the application and see the result. Now we can see that program starts, after we have a message bye, program ends, and later on we have a hi. The latest messages say hi, so the program waits until our Go routine will be executed. We can also check the number of coroutines that currently exist using the runtime package. Let's import first of all it. We can print one before say hi and one after. And let's print the same after calling say hi. At the first message we have coroutines count is 1, and in second message we have 2 because we are creating a new coroutine here. But why we have 1? Because the main function is also coroutine. So we already have one coroutine when we just started, and calling say hi we are creating the second coroutine. Welcome back. In this video we will cover topics, basics of creating channels, sending and receiving data, buffered channels, and synchronization between coroutines. First, let's talk about what channels are. In Go, channels are a powerful feature that allows coroutines to communicate with each other and synchronize their execution. Think of them as pipelines through which you can send and receive a data. Channels are typed, meaning you can send the data of a specific type through a given channel. The syntax of creating channel is pretty simple. We can use make built-in function to create a channel, and inside we have to specify a value type of the channel. Let's look at an example. Here we have creating a channel ch that can transport integer. Now let's see how to send and receive the data using the channels. In this example, we launch a new coroutine to send the integer 42 into the channel ch. The main coroutine then receives this value from the channel and prints it. It's important to note that the arrow is used to send and receive data from the channel. The channels can also be buffered. A buffered channel has a limited capacity to hold values before they are received. Let's see how to create and use buffered channels. Here the channel ch is buffered with a capacity of 2. This means it can hold up to integers and before any receivers are required. We send the integers 1 and 2 into the channels and then receive and print them. Now let's discuss a common use case, synchronizing coroutines. Channels can be useful to signal about completion between coroutines. In this example, we use done channel to signal when the coroutine has finished its work. The main coroutine waits for the signal before continuing, ensuring synchronization. Welcome back. In this video, we will learn about race conditions and mutex. First, let's talk about what a race condition. A race condition occurs when two or more coroutines access shared data and try to change it at the same time. Without proper synchronization, this can lead to unpredictable and incorrect results. Imagine you have two coroutines A and B, both are trying to increment the same counter variable. If they run concurrently without any synchronization, you might end up with a race condition. Let's see it in the example. I am creating global variable counter and initializing the 0 value. Create a function that will increment the value of the counter by 1. In the main function, we are also creating a loop that will do 1000 iterations. Also, I forgot to add the wait group, which we will use to keep track of the coroutine completion. And inside the loop, we will create the anonymous concurrent function, which will call the increment concurrently. In this example, we are creating 1000 coroutines to increment the global counter variable concurrently. If we run the app, we'll get the different results. The main issue is that the counter plus plus operation is not atomic. It is consists of multiple steps: read, increment, and write. For example, coroutine 1 reads counter, let's say the value is 42. Before coroutine writes back the incremented value, coroutine 2 reads counter, which is still 42. Both coroutine 1 and coroutine 2 increment the value they read, both to 43. Both write back 43, but the correct value should have been 44 after both increments. This is what is called race conditions. To fix this, we can use mutex or mutual exclusion lock to protect counter variable. Mutex provides synchronization between concurrent coroutines to ensure that only one coroutine can access a shared resource at a time. Lock function locks the mutex before accessing the shared variable and unlocking the mutex. Now code ensures that the counter variable is correctly incrementing to 1000 without any race conditions.